distributed data storage and distributed data processing. Okay, so that's the two main purposes that Hadoop really solves, and some of the key, things that you try to guess. The important thing is it achieves this even if you use just commodity hardware, right? So you don't need $1 million to do this. In fact, there's an interesting blog post that one of my team members sent me, where they have set up a Hadoop cluster using Raspberry Pis. You've heard of Raspberry Pis? So these are $25 computers. You can, the size of, I guess, about this much in size, and you can slip it into your pocket. And some person, just for a lark, he actually set up a cluster. Of course, it's a toy cluster. So you can do it with commodity hardware, right? So distributed data processing and distributed data storage. Next question, let's give the other teams a chance.
Anybody working right now in that area?
Anyone on Raspberry Pis other than? Are you working on Raspberry Pi?
I'm looking to. I want to put my hands on BeagleBone rather.
Sorry?
I want to put my hands on BeagleBone. BeagleBone has got a CPU in there.
Okay.
And it's more powerful alternative to that.
Okay.
And
Looks like a potential ExpertTalks
$45
topic for us.
ExpertTalks topic, I guess.
Okay. So distributed data storage. How do you achieve distributed data storage in Hadoop? What is the component of Hadoop that gives you distributed data storage?
Hdfs.
Negative marking. No. I mean, I'm saying basically let some of the other teams get a. But yes, that's the right answer. It is Hdfs, which is Hadoop Distributed File System, right? And what is it? It is an abstraction. It lets you access data in Hadoop just as if it was a regular file system, right? But it has the characteristics that the data is distributed, okay? However, it is not, it is completely transparent to you, right? To you meaning the user and the applications. You need not know where the data is stored. And Manira mentioned failover, right? Failover is more related to processes, but for data storage, what you get with Hdfs is you have reduced chances of losing data. Okay, so that is Hdfs. Someone there, if the next question is, how do you get distributed data processing? What is the component that gives you distributed data processing? MapReduce. So the component of Hadoop that gives you distributed data processing is MapReduce, right? And what is MapReduce? It is a particular class of algorithms. MapReduce. So the next question is MapReduce something that is proprietary to Hadoop? Anyone else? Manira? No, anyone with a yes?
I mean, MapReduce, like Hadoop borrowed from Google. Google invented it. And so it's like algorithm.
Not really. I don't even think that it is Google that
Google
invented MapReduce. MapReduce has been around as a class of algorithms for a long, long time. So MapReduce is not something proprietary to Hadoop. It's just a class of algorithms, right? And we'll see very quickly. In fact, we'll go over the MapReduce exercise today, and we'll see what is it that is peculiar to MapReduce, which distinguishes it from other kinds of algorithms. Okay, so and Hdfs, the two main components of Hdfs. Anyone here? The two main components that the building blocks of Hdfs.
Name node
And who were our name nodes and data nodes last time from the role play? Yeah. And
data node.
You're also a data node, so our name node is missing.
It's a big controller.
So the single point of failure is missing. So I think we should cancel the meetup then. So Hdfs, the main components of Hdfs are a name node and a data node. Okay. So when you give your data, when you put your data into Hdfs, right? There are two main components that handle how data is stored and retrieved, and they are called the name node and the data node. The name node is the key player because the name node maintains information about which are the data nodes, right? Where are they located? And what it does is each file can correspond to multiple blocks within the Hdfs file system, right? Every file system uses the concept of block, right? Anyone, can you tell me very quickly about what is a block as far as the file system is concerned? Is it a higher level concept or a lower level concept in the file?
Lower level concept. It's a
lower level concept, right?
Locations.
And what is it actually? So if I have a file that is, let's say, 20 megabytes, right, with a particular file system that has a block size, let's say, of 512 kilobytes, right? Can you say how the blocks in file are related?
Components putting together.
So essentially,
No, I'm talking about a regular file system. I'm not talking about Hdfs.
right, so essentially a file is divided into offsets, right?
Mayank, will someone do the mic running for us?
Okay, so file is divided into offsets, right? It starts with 0 and until the file size, right? And this, I mean, essentially you can also see a file as, a set of chunks, right? And these chunks are mapped to the blocks essentially, and so they are actually essentially the blocks. Although the offset look contiguous, but the blocks may not be, right? So the offsets are basically broken down and they map to block, and these blocks can reside anywhere in the disk in a distributed manner. So it's the job of file system to present that consolidated view and put blocks together in the form of offsets as you access the file. So this is summary.
Yes. So the block is actually the unit of access, right? The actual data access as far as the disk is concerned, right? Somewhere you have your storage. It might be disk. It might it might be your hard disk, etc. And the block. So what is the block? It is the unit of access. It consists of the contents, right? If your file is like a suitcase, the blocks are the contents in the suitcase, and the blocks are each usually a standard size for each kind of file system. And when you read data, the file system reads one block at a time, okay, regardless of whether the data occupies the entire block or not, right? So in the same way, Hdfs, the Hdfs file system has a block, right? And all the files that you put into Hdfs correspond to one or more blocks. And what Hdfs does is, it has a replication factor, which is what Mohammed mentioned. For each file, you can specify a replication factor, which is by default a value of 3, which means that your file, the blocks in your file, are going to be distributed across multiple data nodes, right? And what does the name node do? The name node doesn't do any of the hard work. The data nodes actually do the storage and retrieval, right? And the name node has the information. It has what is called okay, this is again slightly technical question, but we are all technical people. So I think I had mentioned this. Do you know what are the two main things that the name node uses to actually manage this information? the information about what files, right? How those files are organized, who are the data nodes, where the blocks for the files are located. Do you know the two components?
Job
Anyone?
tracker, job tracker and draft tracker.
No, it's not the job tracker. I'm talking about two files that are present on the name node, which it keeps, which it maintains. Its main task is to maintain these files and to serve requests by clients.
Secondary name node.
No, the secondary name node is just the backup name node, so standby name. So the two files, there are two files. One is called the namespace. Okay, the namespace is your record, and one is called the edit image. Okay, so what happens is, as new files come into Hdfs, or files are moved around, okay, or blocks move between data nodes, right? What happens if a data node goes down? A name node will have to move the blocks, right, which were present on that data node. There might be some set of files for which the blocks were out of, let's say, three blocks. I mean, 3 copies of each block. Let's say 1 copy was on that particular data node. So if that data node goes down, then the name node has to arrange to move the copy of those blocks from the good data nodes to one more data node, right? To ensure that the replication factor is maintained, right? And so, how does this happen? So this kind of transaction is recorded in what is called an edit image. Okay, so the namespace plus edit image is your latest metadata, right? What files, how are they organized, where the blocks for the files are located, and which data nodes have those blocks. Correct? So that's the namespace and, name node and data node. Okay. Yeah.
So let's say if the node comes back, would the redundancy be more than the record redundancy?
Yeah, that's okay. I mean, it's okay for, there will always be times when a particular block is replicated more than the minimum replication factor, and a particular block is replicated less than the replication factor. Okay? But those are like temporary imbalances. And in fact, there is something called a balancing that takes place in Hadoop, where it sometimes reorganizes and moves the blocks around. Okay? So any suggested, now it's your turn. You want to ask me any questions? Any suggested quiz questions around HDFS?
Why MapReduce?
Okay, out of syllabus. No, I was saying I will of course answer the question. But about HDFS, if you have any questions. We did a role play last time about how data is written to HDFS and how data is read back from HDFS, right? Any questions about HDFS?
Suppose a computing node is want to read a file, so we will go and ask about name node where that file exists and it grabs the data. Suppose he asks again, then he again goes to name node or he bypasses the name node?
I think the answer is not. I think it's fair to say that I don't know the answer. And the second thing that it is fair to say is that even you don't need to know the answer. Right? Because, okay, let me explain. I'm not saying that you don't need to know the answer. What I'm saying is that when there is some, so when you say the scenario that you talked about, right? There is some process that wants to read a file out of HDFS. So by definition, this process has become a client, a Hadoop client, right? An HDFS client, which means it uses a set of libraries, right? Supplied for that Hadoop distribution, right? Which hides all these internals from it. Okay. So, frankly, that process really should not care or need not care about whether when it attempts to fetch or to read a file, okay, and if it was returned a list of the data nodes that the blocks for the file are available from, okay, will it get the same? You asked whether it will just use what it had already.
Yeah, means it caching the things or not? It's those named information.
Yes, so I suspect that it will not really cache it because of two things. The way that the Hadoop name node will return the list of data nodes that you can start reading the blocks for each file, okay, that is actually optimized for where you are located on the cluster. Okay, so if you take, let's say, two machines which are in the cluster, how can they be related to each other? This is a quiz question, by the way. There's a terminology. In your cluster, if I have any two machines, any two nodes, right, with respect to the network, with respect to the topology on Hadoop, they can be related to each other in only two ways. It has to do with a networking term. Sorry? No, it's not ring topology.
Switch,
But-
network switch.
Bonus points for trying.
Switch, this is the switch.
You're very close to it. I think someone got it now. Right, yes. So how it is two nodes in the Hadoop cluster, right? A Hadoop cluster consists of a number of
Right.
boxes, nodes. They are all connected, okay, over the network, and they are identified as part of the cluster, right? So if you take any two nodes, they are related to each other in only two ways. One is that they are either on rack or off rack. Okay, on rack means that if I take a cluster with a significant number of nodes, anything from 15, 20, 30, 40, 50, okay, and if I start to put these boxes on a switch, there is a limit to how much traffic a particular single switch can handle, right? A switch can have at the most, let's say, 20 or 24 ports, and that it is actually limited by the underlying physical limitation of bandwidth, right? Regardless of how fast you make that switch, etc. With a protocol like Ethernet, there is a physical limitation, right? So what happens is, as your Hadoop cluster grows, your nodes, all the nodes that are on a single switch that don't have to cross, when they send some traffic, okay? Suppose I have a name node and a data node, right? If the traffic from the name node to the data node does not have to cross that switch, okay, they are on rack, right? They are closer to each other. But if it actually has to cross a switch, of course, when you say one switch, it means at least two switches it will cross, right? Then they are off rack. Okay, and Hadoop actually, both the name nodes, the name node actually is conscious of this, because when you set up a cluster and when you add nodes to it, you can actually tell which rack a particular node, particular box that you added. Okay, and remember that this rack actually in Hadoop, this rack is not actually you don't have to physically have 3 switches to have 3 racks. Okay, even if I have just 2 boxes connected directly to each other on a hub, I can say that one of them is on rack 0 and one of them is on rack 1 to simulate on rack and off rack behavior. So it is for the person who's running the cluster. Okay. So coming back to Mohammed's question. So can you repeat it, please?
Why MapReduce?
Yeah, why MapReduce? So typically once again, MapReduce is not proprietary to the Hadoop. It has existed as a class of algorithms for a long, long time. It is available on other computing platforms and not just Hadoop. And you could just, you could just write MapReduce with practically any programming language. But with large data, okay, and with the kind of processing that you want to do on large data, okay, it is usually, the pattern is that you read most of the data. It is not like a relational database access, for example, right? What is the pattern for database access with your conventional relational databases? Anyone?
Tables format.
Sorry?
Tabular format.
That is how data is organized. But how do you access it?
Queries in terms of queries.
Yes, you do queries, but okay, if I have a table with 1,000,000 rows in it, okay, more often than not, do I read 1,000,000 rows?
No.
What do I read or update?
Index.
Yes, so it is indexed and it is random, correct? And you are accessing at the most a few of the rows, right? Unless you have a really poor DBA, right? You are not going to do full table scans all the time where you are reading all 1,000,000 rows, right? Every time a user wants to log in, you are not going to read all, 1,000,000 rows and then say, okay, this user is present, right? There's an index there, let's say by a user ID or a login, which retrieves one or a few rows for you, right? Whereas, so MapReduce is not suited to that. MapReduce is suited to scenarios where you have huge volume of data and most of the questions that you ask or the kind of interesting things that you're looking for, you're going to read a lot of that data or almost all of that data. Okay? So MapReduce is suited to that class of algorithms. And Hadoop, because it is used for distributed data storage of large volumes, MapReduce is the natural choice, okay, for the processing that you do in Hadoop. Does that answer your question?
Yeah, like couple of more points, like key value there is immutable. So you can, when you are processing on distributed clusters, so one can assume one key is immutable, cannot be changed. Another thing is like output of mapper will be sorted. There are other characteristics that helps, especially that suits, especially in distributed computing.
Yeah, I think these are, you are right actually. In MapReduce, in each phase, both maps and reduce, right? There is a key and some value associated with it, right? Your data consists of that. But whether or not that key and the key remains immutable or not, I think that is not a hard and fast assumption. Okay? But 99% or 100% of the time, that's just the case. Okay? Because the data that you're processing, it's again large volumes of data. It's not that that data is being updated all the time.
Actually, last time you took a very good example about that MapReduce and how it suits in distributed computing.
Yeah, we'll look at it actually. Question?
You talk about federation namespace and the upcoming Hadoop 2.0.
I can talk a little bit about federation of namespace, but my thought is that maybe we'll get started, right? Because I think for the people that were not in part 1, I'm not sure whether the quiz has made you a little more confused or if it has made things a little clearer. And for the people that were there, I'm sure you want to see, get started with some more stuff, right? So we'll park that question. I'll come back to it. I will answer the question, talk about federated namespace. But the second thing that you mentioned, I am not.
So basically, Hadoop 2.0 is the official.
Hadoop 2.0, okay. I have no idea about Hadoop 2. In fact, I have very little idea about Hadoop 1.0, but that's enough for me to conduct these Hdfs. So, if you would like to speak about Hadoop 2.0, you're more than
It's
welcome.
still in alpha.